Hello, everyone, and welcome to Contracts for Collaboration-Driven Development. My name is Alianna, and I'm Senior Director for API Lifecycle Products at SmartBear. Hello, everyone, and welcome to Contracts for Collaboration-Driven Development. My name is Alianna, and I'm Senior Director for API Lifecycle Products at SmartBear. My name is Alianna, and I am Senior Director for API Having one slight technical difficulty, but I think we can fix it. Let's see. Sorry, folks, I seem to have lost my PowerPoint. Terribly sorry about that. I seem to have lost my PowerPoint, but let's see if we can get it back and deliver the presentation. Ah, look at that. And we're underway. Can everyone see it? Thumbs up from the folks in the chat? Yes? Good. So in the API space, a lot of the conversation around contract-driven development has centered on the question of, did we build the API right? All right, do we have PowerPoint? Thumbs up? Yes? No? Ah, perhaps maybe another 30 seconds will go by. Yes, okay, brilliant. All right, so in the API space, a lot of the conversation is around, did we build the API right? But if we use the contract as a foundation for our common understanding of the API, we can answer not only that question, but the equally important, but ever so much more elusive, did we build the right API? In today's session, we're going to talk about how API specifications and consumer-driven contracts can form the basis for cross-team collaboration in delivering quality services. And we're going to show you some evidence for this from SmartBear's State of the API 2020 report, which just came out. So the first statement I'd like to make is quality requires collaboration. And quality, we can tell now, is more important than ever because the cost of API switching has gone down quite a bit. People are much more willing to switch services or change than they were when we ran the survey in 2018. So it has a potential to become quite a vicious cycle because limited time is the biggest obstacle to quality, but then poor quality and poor performance leads to lost customers. 74% of API development teams said that collaboration is either extremely or very, very important. So it's something that we know as an industry. It's something that we even acknowledge. But what are we doing to get there? Well, first of all, why are we building these APIs in the first place? Now, according to SmartBear's State of API survey, interoperation between internal systems and tools was the biggest driver for API creation amongst our more than 3,000 participants. So collaboration is actually definitional, particularly for internal collaboration. But the second highest ranked driver for building APIs or developing APIs was much more outcome oriented, and it was about improving efficiency. In fact, there were three drivers that had significant year-on-year increases. One of them was partnering with external organizations, that was up about 8%. And then absorbing content or data from external products and also interoperation between internal systems and tools. Those were both up 7% from the previous survey. So we're all moving towards faster development cycles. And while that's happening, the amount of data that we have to contend to is also growing exponentially. IDC's Global Datasphere report, a term that I absolutely love for no real reason, they said that data is going to grow from about 33 zettabytes in 2018 to 175 by 2025. So the why of building APIs is both about what APIs inherently do as interfaces, but also what APIs bring us and bring our organizations. So I want you to think back to the last time you created a new API. The answer to the how of building APIs not so very many years ago was predominantly typing new into your IDE and then proceeding from there. But if you're among the 20% of our survey participants who follow design first principles only, then it's likely that this exercise started with perhaps some engineers, an architect maybe, an expert or two, and a whiteboard. And then there's a certain amount of hope that's involved. You have to hope that the experts understand enough about how APIs work. You have to hope that the architects and the engineers, they get the domain. Then someone takes a picture of your whiteboard for us all to delete later and goes back to their desk, and they create a specification. What this means is at the core of API design is collaboration. And collaboration begins with a shared mission and a shared understanding of the desired outcomes, at least ideally. From this point, there's obviously a myriad of ways that this exercise can go completely and totally pear-shaped, and we've probably all experienced a few of them. But I'm going to talk about some of my favorite ways that either design first can go off the rails, but also how contracts and making contracts the focus of your collaboration can bring you back again. So let's start with a very obvious first challenge. You are in the 29% of teams in 2020 who are not actually practicing design first. Maybe there's legacy services. Maybe you're on that first and highly uncomfortable leg of the design first journey, and you're taking stock of the code first APIs around you, and you're trying to evaluate your generated documentation. In the transition from code first to design first as an approach, the contract, however it's generated, is a bridging solution. The initial foray into centralizing contract management, maybe, or the adoption of the contract as a source of truth. This is not only for API discovery or for documentation, but also for testing and for validation of the API during the DevOps process. That's not to say that documentation in and of itself is not important. In fact, it's taken second position in terms of importance this year in our survey. And this is a 13% increase year on year. When we asked the same question in 2016, for comparison's sake, only 25% of respondents thought it was even a factor versus 63% this year. But we shouldn't get complacent because API documentation also represents a big opportunity for improvement. It's very important to the successful adoption of an API, but 45% of our survey participants said that their documentation was either poor or needs improvement. Most organizations, about 50%, said their documentation was good or average. Only 5% of you decided that it was very good. The next challenge to API design and development is a little bit more abstract. You see, the contract can be considered a build artifact. It could be considered a design artifact. Whatever it is, in the ultimate analysis, whether it was code first or design first principles in play, APIs are created in recognition of a need. Design first isn't exactly contract first. Not if you consider that the contract is, the initial sketch of it is an immutable contract between provider and consumer. For the design first approach to really be effective, for it to deliver on its promise, design predates and informs the specification. So your pictures on a whiteboard, whether that whiteboard is digital or physical, you write up a specification. Now you have a specification for your API and perhaps some other business requirements. So what happens next? Do you just build? If we were architecting houses instead of services, then the designer would know how to formulate an executable blueprint. That's a pretty low bar though, right? So I would certainly agree that it's important that the the builders follow the plans about where do the pipes go, right? But everything can be built correctly, built to spec, and it still wouldn't serve the need that it needs to fulfill for the audience that you're building it. And the same thing is true of services. If you don't use that spec as a foundation for collaboration, then arriving at a communal understanding of what the API does and how it does it is like executing a blueprint without thinking about how a building will be used. Again, the means to solicit feedback from this broader community is at the intersection of tools and the specification. There's a duality to specs. They're machine readable and human readable. In practice, this means you don't need to ask for feedback on some gnarly back of the napkin version of your spec. Using API mocking or virtualization, you can create from the spec a living example of your API. You know, our State of the API survey, the survey itself, was conducted in May of this year. So many of us had been living under quarantine conditions for a little while. What was really interesting to me, one of the very interesting things on the survey was that some of the techniques that had a spike in interest directly correlated to the challenges of remote collaboration. And one of those particular challenges was service virtualization. Interest in service virtualization upticked 10% over the last time we ran the survey 2 years ago. If you think about it, it makes sense in a way. You know, users, partners, your documentation writers, they can actually interact with the API before a single line of code is written. And then they can also give feedback. And the great news about this is, because the feedback came early enough into the process, you're actually going to incorporate it into the specification and ultimately into the code. So keeping design in design first requires engaged listening with your consumers, and it's not always to what they ask you for, but for what they do in the API sandbox. They can all interact with the API before the code is written and give your feedback. And that's important because it gives you a more broad, diverse amount of feedback to your API and whether or not it's actually meeting the functional requirements. It also improves stakeholder engagement, which is a key to API adoption. But more broadly, you get to see if the idea that you had and that you captured in a specification is effectively the right API. And when you take this holistic look from engineers and designers and SREs and SMEs and security and hey, your partners, you stand a much better chance of building the right API because you can enable lightning fast design revs using the specification. For the majority of APIs, this kind of collaboration should not be a one-time thing. It's something that occurs over time, and it involves a large number of people. So let's say you code an API, and as a step, maybe it's even the final step, the API build is run against the specification to test for conformance. But that testing is a one-time check. It's not an ongoing process. So what happens in these organizations when it's time to evolve the API? We know most APIs have to iterate. Sometimes, you know, and I've heard this recently at conferences, they talk about microservices as Kleenex APIs. Instead of actually evolving the APIs, they wind up having to just dispose of them and rebuild. And that winds up taking up a lot of effort and time and can cause some problems with downstream implementations. It can be a really big problem, but equally bad can be when the API build falls out of conformance with the specification. As you iterate, this becomes an issue. So again, imagining that you're an architect, the kind that builds houses this time, and let's just say you never checked to see if the house that the crew built was aligned to your blueprint. Think about the impacts that that could have when you're planning an addition to the structure. You know, what if the construction engineers move the load-bearing wall? So the consequences could be disastrous, but minimally, it's wasted time, it's rework. Instead of performing manual checks on the endpoints or comparing it against the documentation visually, or even running a one-time test between the build and the contract, Because specifications are designed to be machine readable, it's actually straightforward, relatively, to automate producer-side contract tests and then add them directly into the build pipeline. And by the way, this chart, also from our survey, lets us know that design first, approach only, that's about 23% of our respondents. But design first and code first, that's happening a lot more frequently. But in this scenario, every pull request could trigger a contract test. And then the builds that are out of conformance with the specification won't be promoted to production. So if style guides and rules have been incorporated into the design system and then followed in the design, it stands to reason that the contract test can also confirm that the governance rules were followed. And then, the consumers of the API benefit because no one really enjoys working with inaccurate, poorly documented APIs. So the specification is treated like another piece of code. Similar workflows can be established with the version control system. And contract-driven development from this angle looks a lot like test-driven development more broadly, right? So the producer-side contract test describes a new piece of functionality that's going to be added to your API. When that spec is pushed into a version control system, it triggers a pipeline test, and the tests will flip to red because the new content hasn't been built. Then the engineering team is alerted to pick up the work and execute the new code and flip the test back to green. And this is important because one of the biggest challenges that we saw in this year's survey was around staffing and standardization, and also the amount of time it takes to sort of build and deliver APIs. We have less and less time. We are moving faster and faster in terms of engineering and deployment. And so the only way of sort of manufacturing those extra hours in the day is by achieving better coordination with our teams. In today's keynotes, we talked a little bit about governance, sometimes a dirty word, but it's a huge, huge issue, and especially as organizations try to scale their API programs. The rules in place for OAS specifications, those in some cases are going to need to be adapted as other specs are adopted or used. In our survey of more than 3,000 participants, customers definitely had a preference for OpenAPI, formerly known as Swagger. And it continues to be a very high, but there's also dramatic growth for both GraphQL and also gRPC standards. We're seeing a little bit, I think, specialization in the standards where, certain specification formats are being chosen for their suitableness in particular areas of API development. There was a more than doubling of interest in gRPC from our survey over 2018, and a 50% gain for GraphQL. Yet, despite this growth, about 82% of our survey participants said that OpenAPI was their standard of choice when they were defining their APIs. Standardization also is a challenge as you try to build more APIs faster. And by allowing some of the decisions to live in the API standards, it makes it a lot easier for teams to focus their creativity on the content of their APIs instead of structural things like decisions about snake case or kebab case, or whether or not endpoints should be plural. There is an added benefit to integrating contract tests into your CI/CD pipeline as well. And it's kind of like a bellwether for some better or improved alignment in your dev organization. You're cutting down the lag time between committing a change to the spec and engineering picking up that work, no matter who's initiating that pull request. And then the alignment between your documentation and your build always gets confirmed. You know you're building the API right. But maintaining connection between the spec and the live service is an important aspect of how you actually evolve your API. And a producer-side contract test can also alert teams to disengagement on API collaboration, because failures downstream happen when designers and developers aren't in agreement about the API or how it should behave. So the main purpose, know that you built the API right, but I think contract tests also are a bit of an early warning system for when the API may have veered from the path of building the right API, because the specification is no longer the foundation for describing what you'll do next. So the next challenge is meeting the other contracts, consumer-driven contract testing. So far, we've focused on things that are in our control as API providers. But now we are going into the unknown and discussing the whole point of providing APIs, API consumers. So whether they're internal to our organizations or basically anyone on the internet who knows how to call a public API, consumers are both the intended target of our APIs, content, and one of the chief reasons that design first is very difficult to maintain. API consumers make our lives difficult in a number of ways. Number one, they actually use your APIs in ways that they largely will not share with you. Even the best telemetry in the world can't tell you all that they do or use within your API. Transactions could occur outside the observed window and they won't be documented, for example. Consumers cause security problems, particularly when those consumers are hackers. And in certain architectural patterns, like event-driven messaging, for one, they can be entirely anonymous and unknown to you. And you won't be able to find out who they are until you change something and then something breaks. And then they'll make themselves known through their rollback requests or hotfixes. And finally, they use your APIs wrong. Even after all that gorgeous documentation that you generated, if there's an endpoint out there, somebody's consuming it, and even maybe the one endpoint that you probably should have deprecated when you were migrating from your monolith, for example. In the end, you can have the most well-designed API with brilliant, interactive, polished documentation. But as an API producer, you can only know your world and the content that you create, which means you don't know the hearts, minds, and implementation details of your consumers without a contract. The consumer-driven contract test is a way to answer, did you build the API right? Only this time, the API provider is not the one who's asking the question. The consumer-driven contract test I think of as sort of a formalized request that you stop breaking someone's downstream implementation that utilizes your API. And even for internal APIs, the audience can be very considerable. You can picture sort of the absolute rabbit's warren of microservices that your organization is required to maintain. And they keep on multiplying until your architectural service diagram vaguely resembles the Death Star. This one. And that was in 2008. But we know that microservices are proliferating. In fact, most of our survey participants said that the technology area that will drive most API growth in the next 2 years is microservices. But we're also seeing a pretty big mismatch going on, which is teams are very concerned that limited skills and experience is posing a huge challenge to microservice success. It's hard to find developers with the appropriate experience or skills, and especially when the microservices implementation is replacing a former monolith. Decoupling and domain-driven design are neither easy nor fast to implement, and there's a lot of complexity of the existing code that is putting a challenge on the teams that are asked to implement these changes. And there isn't just one consumer, but in certain cases, the extent of your API's audience can be known, like in microservices. However, there are a lot of ways that those consumers can potentially break something. And many of those things actually go outside of the boundaries of the API specification itself. Implementation details like the structure of a response, error handling, especially if a consumer is implementing particular business logic. The event type or payload. So changing the event type in an event version of, is it event version of the, is the event-driven version of messing with a REST resource. So consumers will need to listen to the new type. Same thing with event payload. It's similar to changing the response structure. Rate limiting is another way you could potentially break a contract, and even content distribution, like moving your API behind a CDN. If you wait until your API is in production, doing the final pass of tests before your deployment, it's likely you've waited too long. So instead of testing against the deployment candidate, maybe create a virtual service, run consumer-driven contract tests against the mock, incorporate the feedback. Also, if all of your consumers are providing up-to-date contract tests and the assets are centrally managed, it could be possible to further simplify things by deleting unused endpoints, because you'll know, truly know, what's being used and what's not. So in closing, the act of designing really should be an ongoing collaboration that's facilitated by specifications as teams iterate. A spec can bridge code and design-first approaches. Using the spec to perform user acceptance testing before you write a line of code is an excellent practice, and one that we are seeing people get a lot more interested in. Keeping design in design first, so that it's not design first at first, by integrating producer-driven contract tests to build pipelines, and then use consumer-driven contracts as a means of understanding the impact of any change. With these tools, you can be confident that you've built the API right, and you've built the right API. promo. I'll be posting these slides online and also into Sketch after the talk today. Thank you so much. The one that I'd like to ask myself is, how do you use Zoom, which I really use every day, multiple times a day, and I'm so surprised that I wasn't able to use today. But thank you for your patience at the beginning. Also, please feel free to go online and check out the SmartBear State of API 2020. The stats that I presented today are from that report, and there's a lot more in there as well. It's a pretty cool report. All right. If you have no questions, then thank you so much, everybody.